Hello, and welcome to this installment of the Future Grind podcast. I'm your host, Ryan O'Shea, and today I'll be speaking with Suzy Teele, the head of marketing and communications for the Advanced Robotics for Manufacturing Institute, also known as the ARM Institute. ARM is a Department of Defense-funded nonprofit that accelerates the advancement of transformative robotic technologies, artificial intelligence, and education. They spun out of Carnegie Mellon University and are a consortium of more than 200 members, including Intel, BMW, Lockheed Martin, Yaskawa, and many more. We discuss the future of automation and advanced robotics, the government's interest in manufacturing, projects in development, and much more. This episode is brought to you by the Smart Manufacturing Experience, taking place June 2nd through 4th, 2020 in Pittsburgh. This event provides solutions for applying the latest smart manufacturing technologies that drive results. Share your smart technologies to an audience eager for the latest innovations and know-how in Industry 4.0. Smart Manufacturing Experience focus areas are artificial intelligence, augmented and virtual reality, cybersecurity, additive manufacturing and 3D printing, automation and robotics, data analytics, industrial IoT, and workforce transformation. Be part of the experience to connect face-to-face with qualified decision makers searching for these disruptive technologies. Visit bit.ly/SMX2020 to become an experience partner. That's bit.ly/SMX2020 to become an experience partner. As always, show notes and links are available at futuregrind.org. We're on iTunes, Stitcher, and wherever podcasts are found. A video version of this episode is posted on Facebook and YouTube. Make sure to subscribe on all of these platforms, leave a review, and you can also like, comment, and share to spread the word. If you'd like to keep this podcast running, you can donate at futuregrind.org/support, or you can purchase some of our newly released products at futuregrind.org/store. Because of you, this is Future Grind. All right, and now we are here with Suzy. Suzy, thanks for joining us.
Oh, thank you, Ryan. It's a pleasure.
So, what is the ARM Institute, and why does it exist?
The ARM Institute was started, and by the way, ARM stands for Advanced Robotics for Manufacturing, was started in January of 2017. And our mission is to advance the state of robots so that they are more available to manufacturers across the United States. Right now, very large manufacturers use robots in industries like aerospace and automotive, but the average small or medium-sized manufacturer who may be looking at ways to increase the automation capabilities in their facility because they want to increase throughput, or they are struggling with a nationwide problem, which is lack of labor, a small labor pool, don't really have the capability or the understanding or the resources to easily use robots. And part of our mission is to help extend capabilities with robots to make them more accessible to all audiences and all manufacturers nationwide. We are actually part of a broader nationwide initiative that's funded by the federal government called Manufacturing USA. This initiative was started in 2008, and there are 14 institutes like ARM across the United States that are focused in different areas of advanced manufacturing. Our focus is robotics and AI. There are other institutes that are focused on lightweight materials, additive materials, 3D printing, flexible electronics, and things of that nature, advanced fabrics. And so the goal of these 14 institutes is again to advance technologies in these areas to strengthen the United States manufacturing base and make these technologies more readily available to manufacturers.
So, how did all of this get started, and how did it go from an idea to reality?
Great question. Actually, Carnegie Mellon University was the impetus behind this, and there was a request or proposal that came out from the federal government that said that they were hoping to start another institute focused around robotics and AI. And Carnegie Mellon University, along with several other organizations who were never named, put the bid in for that, and Carnegie Mellon won the opportunity to form this would be the 14th institute. And so we were created and spun out of Carnegie Mellon University as a separate nonprofit in January of 2017.
So you are a separate nonprofit, but you're actually operating as a national consortium of more than 200 member organizations, spanning everything from manufacturers and research institutions to nonprofits and more. Who are some of these members, and why do they join?
Yes, so the reason why the federal government funds this, just to give you a little background about why we're a consortium, is because they believe that technology advances when you have teams of people that have different views of representation, all come together to solve a problem. And the federal government it's not easy for them to pull that off. And so that's why they're looking to these institutes to help make that happen. And so every institute, but certainly ours, is really made up of several different categories. One is what I call manufacturers themselves, and everything from some of the very largest manufacturers in the world, like Siemens or Intel or Lockheed Martin or Boeing. They're all United Technologies. They are all members of ARM. But we also have small and medium-sized manufacturers that are our members as well, too. There's some local companies like Accutrex that are members that we're working on projects with them right now. So we span the manufacturing gamut from these very large multinational companies to these small regional manufacturers. Now, in order for these large multinationals to be a member of ARM, because we are funded through the U.S. government, they have to have a significant presence here. So if it is a manufacturer that is based in Germany, but they don't have a presence in the United States, they cannot be a member of ARM. The second category is academia, and that ranges from some of the United States top research institutes like Carnegie Mellon, MIT, Princeton, Texas A&M, all the way down to, on the other end, trade schools and community colleges. So we have a membership that spans all of that because a lot of the training that we'll need to do to create this new class of employees called robotic operators, people who can manage and the robots right there, who can do field maintenance on the robots. A lot of that training is going to come through those trade schools and those community colleges. And so they play a really important role in our ecosystem. The third major category are the suppliers of the technology themselves. Pittsburgh has many companies in that area in the startup world, organizations like RE Squared Robotics and IAM Robotics and Capsen Robotics and Titan Robotics are all Pittsburgh-based companies that are members of ARM. But we also work with some of the largest suppliers of robots in the world. Companies like ABB, Yaskawa, and Fanuc are some of the three top suppliers of robots in the world. And then anybody else who may be making equipment that's associated with that, like sensor equipment and mobility equipment, things of that nature. So that's sort of our third main category of our ecosystem. And then we have a small number of other organizations that might be more government focused, nonprofit focused. They maybe have a specific mission for reskilling veterans, for instance, and those types of companies are part of the ARM ecosystem too. So the nice thing is that you do get this combination of perspectives. And what we do is we put together project teams, and when we draw from all these different areas. So a project team just can't be a research institute. It has to be a research institute working with a supplier, working with a manufacturer who has a problem to solve. And that's the way that we can really look at every issue from all angles to make sure that the technology development that we're funding will have more applicability when it makes it to the commercial world.
So we talked a few times about the funding from the federal government for the ARM Institute, but where does that funding specifically come from? Which branch or department of the government is funding you? And is that the only source of funding? I imagine the consortium members pay in as well. Are there any other ways that you make money?
So there are 14 institutes. 8 of them are funded by the Department of Defense, 5 of them by the Department of Energy, and 1 by the Department of Commerce. So it certainly is, from a federal government perspective, spread across multiple areas. We are one of the 8 institutes funded by the Department of Defense. So that's where our primary funding comes from. It was $80 million over a 5-year period with 7 years to spend it. So that was our initial amount of money that we got. Members contribute 2 ways. There are membership fees. We do have membership levels where there are no fees, especially for startups. For instance, there's no actual cash that they have to hand over, but every member has to do that in-kind contribution, what we call cost share. So that could be captured as involvement. Last week we had our annual member meeting. It was our 3rd annual one. We had 250 people in, representing about 180 of our member organizations for about 2.5 days here in Pittsburgh. And that is active participation in our ecosystem. So that counts against their cost share, if you will, their in-kind contributions, the fact that they are spending their time here working with us to grow this ecosystem and to solve these problems. So that's a membership model. So we do get some fees from that because people that are at different levels of membership, if you're at a higher level of membership, you can lead a project. Pretty much anyone can be on a project, but not anyone can lead a project. And so there's just some differentiation in levels and influence from that perspective. But for the most part, all of our members can be very active and be involved with a lot of other things that we do here as well too. So the majority of our money today comes from the federal government, the Department of Defense. We have some funding that comes in from our membership fees, and we are actively working on what we call our next stage of our organization, which is how we become a sustainable entity once the government money runs out. And we have a lot of opportunities and options available to us, so I don't have anything to announce right now. We're still evaluating those, but there are opportunities for us to play a role in either getting continued funding from the federal government because robotics and AI is critical to our national defense, getting our own consulting services off the ground to help with some of these issues relative to testing of new technology and proving out concepts. So there are a lot of ways that we could go, and we're pretty excited about what those paths could be. And we know that ARM is going to be in Pittsburgh for a long, long time.
So anytime the Department of Defense and Advanced Robotics and AI are mentioned in the same sentence, people's minds get to wander to Terminator-type situations, and they think about robots used in warfare. But what you were focused on seems much more benign and focused on domestic issues and manufacturing and workforce development. But how do you view this, a lot of the controversy around advanced robotics being funded by the DoD? And I'm sure you get a lot of this as the head of marketing and communications for the ARM Institute. How do you approach these issues?
No, great question. And I think there's a couple things to think about. One is we don't have to go into all the politics of it, but the truth is that most of the products and services that we use today are not made here in the United States. And that's actually a national security issue because it's very hard to predict the future, right? We don't know what kind of relationships we're going to have in the future with different countries. And the Department of Defense is worried about what if we have a bad situation with a country that makes most of our electronics? We don't make any electronics here. Can you imagine a situation where we can't get phones or laptops? And so it is a national security issue to try to bring more manufacturing back to the United States and have more of a balance. It's not saying everything is going to be ripped out of every country in the rest of the world, but we don't want to have these very high levels of reliance in other places when we have the capacity to do that work ourselves here. So that's probably the biggest reason why the Department of Defense is interested in funding initiatives like the Manufacturing USA Institutes, like ARM. So that's key. The second thing is, the truth is we always find ourselves in situations of war, right? That's the history of the world. And so don't we want to do as much as possible to protect our warfighter, to help preserve their life as much as possible, to help them not have to be involved in situations that are very challenging. And, I'll just bring up an example of one of our local companies, RE2 Robotics. You might be familiar with them. They've been working with the DoD for quite some time now, and they make 2 armed robots that go out and defuse bombs. That's a great thing, right? Can we stop bomb production? I don't know. But can we save the warfighter's life by sending a robot out to find the bombs and defuse the bombs instead of a human? Well, to me, that's an admirable thing to do. And so I think it's important to think about the fact that a lot of what we're trying to do is to protect our nation, to bring more jobs back to the United States, and to protect our warfighters if we do find ourselves in a situation where we have a conflict somewhere.
So, what are some of the projects that ARM is working on now? Is there anything that you can go into detail with of what we are working towards and what you're hoping to accomplish?
Sure. We've got 49 active projects right now, which we think is pretty good considering we've been around. We did our first project call in the, they actually, our projects really started to kick off in the spring of 2018. And they really focus on what the federal government has something called technology readiness levels. And people who work with the government and get funding from the government will understand this. The government looks at a scale of 1 to 10. 1 to 3 is basic research. That's the type of work that somebody like a Carnegie Mellon or an MIT would do. A professor would be doing research on a brand new idea. We work in the area of 4 through 7. And what it is taking some of this research that may have been developed either in an innovation lab at a manufacturer or at a research institute, and then trying to take it to the next step where we can get it to a prototype point where we're actually focused on solving a specific problem. And then what we would do is we would either those organizations that were involved with the project would focus on steps 7 through 10, which is really commercialization and getting it out into use, or we would find companies that might be interested in moving that technology forward. So we really focus in this area called applied research, which is taking concepts and trying to move them closer to commercial viability. So on that note, we do a lot of projects to solve some problems that fit into some of those categories that we talked about, like dull and dangerous, or some very surprising ones. Here's a very surprising one that most people don't know that we're funding, is that, as you probably are familiar with New England, we catch a lot of fish in that area, right? And there's great seafood in that area. A lot of that fish we package, we ship to Asia for processing, and then we ship back here to further package so that we can eat it. Here we're sitting in Pennsylvania, a couple states away from where, and not too far from the coast where this food is being caught. And the seafood that we're eating, some portion of it is being sent overseas to be processed and brought back to us. Well, that doesn't make sense. Why did that happen? That happened because of labor costs, right? And so one problem we're trying to solve is, can we replicate some of the things that a human does for fish inspection so that a robot can do it, so that we can do more processing of our own food that we catch on our own shores here in the United States? So that's an example where what we're doing is we're funding a project that we're doing with Northeastern University, which is in the New England area, and they're looking at enhancing the gripping and capabilities of a robotic arm and adding some sensing capabilities so that they can inspect the fish and inspect it to see if it's something that is edible or not. That's one example of a project I think most people can understand, right? It's like, whoa, why are we sending something halfway around the world to eat it, right? And that's because it's a smelly, messy job. Like, who wants a job standing there looking at fish and trying to figure out if it's good or not? People don't want that job. And so can we get robots to do that for us instead of people? And then we can bring more of the fish processing back to the United States. So that's like an example of a real life problem that we're trying to have an impact on. Another real issue is sewing. Sewing is an industry which hasn't been modernized pretty much since it was invented. And some huge number, it's like 90% of the clothing that we wear is not made here in the United States. Again, cheap labor in other places. But it's very similar. Guess where most of the cotton comes from that goes into your clothing? From the United States. So we grow the cotton here, we ship it someplace else, they turn it into clothing, and they ship it back to us. What if we tried to improve the process of sewing by finding ways that we can do more automation? Because again, that's a laborious job. Americans are not flocking to that kind of job. What if we can bring robots into that process to try to do some sewing here on our own shores? Two, again, projects that on the scheme of things really could have a significant impact over time over the US economy if we can bring some of that production process back into the United States.
Yeah, I think what you said about why the DoD would fund these projects makes a lot of sense. It would be a huge liability for any region to have to depend solely on imported goods. If those goods are unavailable for any reason, whether it's conflict, natural disaster, economic collapse, or anything else, large populations could be left without necessary items. It absolutely makes sense to want to make areas as self-sufficient as possible, and advanced robotics and AI can go a long way towards doing that. But I'm interested in learning a bit more about how you're tackling these projects. What's the life cycle like? How's the project call determined? When does that happen? And how does it go from a problem statement to a finished solution?
We're a member-based consortium. We've got about 220 member organizations across the United States that fall into those categories that we talked about. And our members actually help us define what the most pressing problems are, right? So we go through a road mapping process. We're continually checking with our members. We've created a technology investment strategy that focuses on some of these key areas that I talked about relative to safety, relative to flexibility, relative to reprogramming. And what we do is based upon input from our members, we come up with a project call. So the US government doesn't really direct us in terms of the project calls that we do, but their goal is to provide us some insight and some advice and advisory capacity to share what they've seen as well too, right? Because anything that we do on the commercial sector, we want to benefit our government sector and vice versa. So that's what we do. So we collect that input, we do the project calls, we do about 2 to 4 a year, and we do them both on the technology side and the workforce side, and I'll talk about workforce a little bit later. And our members team and they submit a proposal and we award some portion of those and we provide funding. They also have skin in the game. They need to, as part of membership, they make a commitment to make contributions as well too. So they're contributing people resources. They may be contributing their facility to do development in. They may have some intellectual property that they'd like to contribute to the project. So all of our members are expected to provide some in-kind contribution. It's called cost share for each project, and we need to track that as a part of the contract that we have with the federal government for our funding. And then they will work on that project, and those projects typically, the cycle's typically a year. By the time you get a team together and you get all the contracts in place and you start the process, and then when a project is done, the output from that project is made available to all ARM members. And so that's the benefit of becoming a member of the consortium. Not only can you get funding to work on projects, but you get access to use the output for the projects within your own environment. The project team then owns the intellectual property, and they can decide to work with someone else to take that technology. They can license it out if somebody wants to take it and explore it further, maybe move it into the commercial sector.
So, just to make sure I'm understanding completely. So, the team that completes the project would retain the intellectual property, but all members of the consortium would have access to use it and essentially have a license to it. Is that right?
It is, but for their own internal use, so they can't commercialize it. So a manufacturer would be able to take that technology, say, for instance, and use it on their shop floor, but they wouldn't be able to sell it unless they decided to enter into a licensing agreement with that team.
Got it. And you mentioned that the ARM Institute was focused on AI and robotics. What would you say the breakdown is between the strict hardware robotics projects that you do and the more software-oriented AI projects?
Right now, the majority of our projects are more hardware oriented because we're trying to get existing robotic technology to be more pliable, more flexible, so that we can solve a bigger number of problems. But what we're seeing now as we move forward is that we're going to see that take that next step. So right now, the majority of our projects are certainly focused around robotics, and there's always a little bit of AI with anything, right? But in terms of being very software AI specific, I see that more as in future calls. We do have some interoperability software projects that we've funded. One of the big challenges in the robotics industry is that there is no common operating language. There's one being developed called Robot Operating System, or ROS, but it's not universally used. And so it's very hard, for instance, for a manufacturer to purchase robots from different companies to use in their environment because they can't talk to each other. So we are really focused, I would call, more on the IoT side, where we're looking at ways to create more integration between different devices, between different robots, so that they can take a bigger chunk of a process.
So the ARM Institute isn't very old at all, as you mentioned, and many of these technologies take a long time to develop and prove. But are there any success stories from the ARM projects that you can point to? Has anything been developed through one of your project calls that is now in the marketplace and doing its work?
Not yet. Ask me in a year. We've again, because we just really kicked off the cycle in spring of 2018, and that takes about a year. Of the 49 projects, we've got 9 of them that are all complete or very close to complete. We will have a lot more next year. But what we do have, which is really exciting, is that we do have several of our projects here at our location at Mill 19 that are in a prototype state, so that someone can come and really understand the project itself, because we have them sitting here. So we have one project that has completed, actually, let me back up. There's one project that has completed that we worked on with MIT, a project called TeachBot, and it is a robot teaching people how to use robots. And it's not that, the cute little robot that you see on TV. It's actually a robotic arm. So it's a robotic arm with sensors that is able to communicate with someone, saying, going through a trade program, and teaching them how to manipulate and use this robotic arm. So that actually is a complete project. There's because it's based out of Boston and MIT, there's a trade school in the Boston area that's been testing that. So we do have that out in the field. We just finished up a wire harness project. This wire harnesses are very fascinating to me because I never thought about it. Anything that uses electronics probably has a wire harness in it. And a wire harness is a thing that holds a collection of all the different wires that are needed to allow that electrical item to operate. So when you think of something like a car or an airplane, they've got incredibly complicated wire harnesses. Those are all assembled manually, and it could be 200 or 300 wires that are part of this harness that all need to come together and all have different connection points. That's a process that fits into that dull but potentially dangerous category. And we actually have 3 different wire harness projects that we're working on to try to introduce robots into part of this. And so the thought is, if the robot could lay out all the wires, then the person can come along, the human can come along and wrap them and connect them where they need to be. But the dull part of that job is laying out 50 or 100 or 200 wires. And so we actually have that on our floor here, a demonstration of how a robot would do a wire harness project.
So, what are the metrics that define success for the ARM Institute? Is it number of members? Is it projects funded? Is it amount of funding? What do you want to see and what do you want to grow? What's the purpose?
Well, ultimately, it will be the amount of projects that we funded that have found their way into either use by the government or the commercial sector. That the investments that we made to improve the handling of slippery items like fish or clothing, the improvements that we've made to be more precise about, for instance, and this is a funny one, like grinding helicopter blades so that, if a helicopter blade is off a little bit, it could cause the helicopter to crash, right? So safety issues, that will be a measure of our success. So the problems that we're trying to solve today are out there in use in the commercial sector. And you're in the startup world, that doesn't happen overnight, right? So you've got usually 5 to 10 years after you invent something before people really start to use it. We're just a couple years into projects, so we know that, we're not going to see that turnaround immediately. Some of our workforce development projects, so we will see more of an impact because it is programs, say, for apprenticeships or programs to provide certain types of training for people. And we'll be able to see some of that impact actually faster. But at the end of the day, it's what impact have we had on U.S. manufacturing? What have we done to make it easier for our manufacturers in the United States to use these new technologies? That's really where we add the most value. And that will be the measure of our success. That's 5 to 10 years down the road, but we're all here to make that happen.
So in a previous answer, you mentioned TeachBot, which you developed in partnership with the Massachusetts Institute of Technology. And I think that's a good example of a product that focuses not on the goal necessarily of advanced manufacturing technologies, but instead on workforce development and training. Can you talk a bit about that? How does that aspect of your goals and initiatives work?
Oh, it's very important. And I know we spent a lot of time talking about technology, but workforce education and training is equally important to us. It doesn't make sense to have these new technologies out there if there aren't humans that know how to operate them, to maintain them, to repair them. And there really isn't a standardization of those types of jobs in the United States right now. So we're really in this really interesting era where manufacturing looks very different from the way that it looked for our parents, but that perception hasn't changed. Manufacturing today is a technology job, right? In many cases, it's operating sophisticated equipment, it's problem solving. It's not, well, I'm not saying that there are none of them left. There are a lot less of those jobs where people are actually, in doing a lot of dirty or dangerous work because of other types of automation, right? Conveyor belts and things like that, and CNC machines. And there's a lot of other technology that's out there that has automated a good part of some of these jobs that have been dangerous or dirty or dull. But what we don't really have is any kind of standardization in the industry around this new career path. And that's something that we are working on very closely with actually our sister institutes, the other 13 institutes, and with the federal government and with many academic institutions across the United States. So today we see a very standard job called a social media manager, right? That job probably didn't exist 5 to 10 years ago. What we're working towards is creating some standardization around jobs that have to do with people who are responsible for buying and programming the robots, but they aren't engineers per se, because engineers are doing a lot of that work today. People are responsible for maintaining them. People are responsible that repair them. People that are doing planning for bringing new automation in. So we see a whole bunch of new jobs that are being created as a result of robots, but there isn't a lot of, a manufacturer can't go someplace and say, I want a robotics technician, because there's not a standardized job description for a robotics technician. So one of the key initiatives that we have is trying to create some of that standardization. The other thing is just we spend a lot of time helping younger people understand that careers in manufacturing are very different from their parents' or grandparents' perception, and that they are well-paying jobs with great benefits, and there's a huge shortage. If you ask any manufacturer in the United States today, likely what their number one issue is it's labor. They don't have the skilled personnel that they need They want to buy robots. They want to buy more automated equipment. They want to take on more work in their factories here in the United States, but there's a labor shortage and there's a skilled labor shortage too, meaning that the skill sets that people may have today aren't necessarily the skill sets that are needed to work in an automated and advanced manufacturing environment. So that's really a focus for us, is to really help solve that issue.
One of the major issues that I see in robotics and AI and software is, you touched upon this a bit, is the lack of standardization. There's no centralized operating system that all different platforms use, that they can interact with each other. The components and ports are often proprietary and not interchangeable. Is there any effort on your part, with perhaps within the consortium or with third parties, to have the membership talk about establishing these standardized protocols so that things can be more of an ecosystem going forward? Or is that not a focus of yours at this point?
It definitely is a focus. We work with the organization. There's an organization out of Texas called SWRI, SWRI, Southwest Research Institute, and they're very focused on the development and promotion of an open source robot operating system called ROS-I, which is focused in industrial. So robot operating system for industrial. SWRI is a member of ARM, and we ask that our members, as much as possible, when they're working on these projects, use ROS instead of a proprietary operating system, because that needs to be developed. I grew up in software, the software industry. I've been in software pretty much not exactly when it started, but pretty close. And it's very fascinating for me personally, because I see some of the issues that were prevalent in the software industry when it first started, which was, everything was proprietary, nothing talked to each other. There was no way to easily share information across different platforms, different applications. Some of those same challenges exist in robotics today. And so we can all see how the software industry has evolved to a place where pretty much any app can talk to any other app, and everything is stored on the cloud now. And so some of the data access issues have been resolved. I'm seeing that in the robotics industry. It's like I'm reliving this again, right? But some of those initiatives to allow that more interoperability and allow these devices to talk to each other, and that's sort of the promise of IoT, right, is really important to us. So yes, we put a lot of emphasis on that. We do have a project that we have funded that's specifically just for software interoperability and trying to advance the state of ROS-I and advance other communications methods so that robots can communicate with each other more easily.
So we talked about the background of ARM, but I'd love to hear your story as well. What's your background, and how did you come to the ARM Institute?
So I have been in Pittsburgh's technology sector pretty much since since I graduated from college, which was 20 plus years ago, and have always been involved with new technologies, new capabilities. I've spent a good part of my career as a consultant helping other startups launch their businesses, and I've spent time running software businesses and bringing software products to market. And so I've always been on the software commercial sector side and really enjoyed it, but was interested in trying something different. And when I heard about the creation of ARM, and I saw that the focus was more of a nonprofit, government funded startup, it really appealed to me personally. I love startups. I love being part of the startup community. And I'm just was helping to build another kind of startup in Pittsburgh, which is a national institute, but it was still a startup. I was the second employee hired. We had to hire people. We had to build processes and procedures and all the things that a normal or any company would go through to create a new company. And now we're almost 3 years old. We've got about 20 employees, and we're in this new space out in Hazelwood Green called Mill 19. And so it's been a fun road as a startup to go from this concept as a second employee to get where we are today.
Yeah, Mill 19 is an amazing location, and I'm definitely going to ask a bit more about that as we move on. But you mentioned a bit of this there, and you could be doing many other things. You've held executive level positions at various companies and have served as an advisor and mentor for numerous startups. But now you've decided to be a part of the ARM Institute. How did you decide that the ARM Institute was the best place to use your talents?
Well, there were a couple things. First of all, it was an opportunity to have an impact on a national level. While I very much enjoyed the work that I've done in my past and working with software companies and helping companies grow, this is an amazing mission, a mission to try to bring more manufacturing back to the United States and to help regain a competitive nature for manufacturing. I grew up in the outskirts of Pittsburgh in a mill town. My father worked at a glass factory. I come from manufacturing, and I personally lived here in Pittsburgh through the 70s and 80s when we saw the devastation from the steel industry and how that took Pittsburgh, which was once the richest city in the world, at least in the United States, and the leader in manufacturing innovation during the first industrial revolution, and to see sort of the loss of that and the rebuilding of that, and the opportunity to actually be part of rebuilding that again, which is really exciting. So I have to say, I grew up in the manufacturing environment, certainly went into software, but that opportunity to sort of come back and focus on the future of manufacturing and what we can do in Pittsburgh to impact the rest of the nation when it came to increasing our global competitiveness was just I like big problems and big challenges, and that certainly is one of them. So that's probably the primary reason why I became involved.
So, the ARM Institute is a nationwide initiative, but it is based here in Pittsburgh. And I think Pittsburgh, the city, is kind of a central character in this story as well. But really, you could be anywhere. So, why is the ARM Institute well situated here in Pittsburgh?
Oh, a number of reasons. Certainly Carnegie Mellon is one of them. The second is because have been for the history of the United States a major manufacturing hub. We understand manufacturing, we know what the challenges are relative to manufacturing, and though while we might not be manufacturing as many products today as maybe we did 50 years ago, we still manufacture a lot of products here. And the third thing is the ecosystem. We have an amazing ecosystem. When you look at advanced manufacturing capabilities, when you look at the robotics and AI companies that have spun out of CMU or Pitt or have chosen to come here because of our ecosystem. So I'd say all those things sort of made Pittsburgh the place to be. I've been working with the Pittsburgh Robotics Network, which is a nonprofit organization that is focused on creating more of a community for the robotics and AI organizations here in Pittsburgh. And we've got over 70 members. And, that's a story that we have an opportunity to tell stronger through the work that we're doing here at ARM, through the work that the Pittsburgh Robotics Network can do, and the city as a whole. We are considered one of the top 3 markets in the United States for robotics and AI. So it's Pittsburgh, Boston, and Silicon Valley. We're the top 3. And of course, knowing me, I want to be number 1. So having ARM here just adds to this position of strength for Pittsburgh in robotics and AI and manufacturing.
So, you touched upon this already, but you just moved into your brand new facilities at Mill 19, which is built within the remnants of a huge old steel mill. Tell us about these new facilities. What's it like working in this location, and what does this new space provide?
So it's such an amazing sense of history, right? I walk in the building every morning and I see that the steel frame of one of the largest steel mills that existed in Pittsburgh up through the mid 80s. And it's on 200 acres of land that has a huge plan for development and creating it and into a space where it becomes another community that's part of Pittsburgh. So I always say that we're the pioneers because we are the first people that are on this space, these 200 acres, with the exception of Uber has a racetrack here. But this first, kind of this plan for Hazelwood Green is really kind of grew out of this strategy to create a hub for manufacturing futures initiatives. And in fact, we share space with an organization with Carnegie Mellon called MFI, or Manufacturing Futures Initiative, and Catalyst Connection, who is our local manufacturing extension partnership. They've been in southwestern Pennsylvania, I believe, for over 30 years, do a lot of work with small and medium-sized manufacturers, are moving here into this space in a couple weeks. They'll be here by the end of November 2019. And so we're really starting to create a hub of manufacturing excellence and advanced manufacturing techniques here. And that's really the vision for Mill 19, is to create that community of people who really are focused on advanced manufacturing, using robotics, using AI, using other types of things like additive materials, and 3D printing and things of that nature. And over time, all those kind of technologies will be actually worked on here. We just moved in July of 2019. We've just installed some of our first robotic arms. CMU will be moving in some research projects in here. And about a year from now, the place will look very different because it will be an active hub where there will be projects being worked on. We've got a 30,000-foot high bay area. In fact, our whole first floor is just really for projects, research projects, advancement projects, testing technologies, prototyping technologies. And so while that part of the facility is just being built now, as I mentioned, in about a year from now, it'll be a really incredible place where we will see some of the newest and latest technologies for advanced manufacturing being worked on as a combination between CMU research students, funding and projects that they do with various organizations, the work that we do, and we can exhibit and work on some of those projects here as well. And then Catalyst Connection has the very strong ties to the manufacturers in southwestern Pennsylvania. So over time, it's going to be, as I mentioned, an amazing place for advanced manufacturing.
Yeah, I think it's really interesting that these sites that used to be very industrial in making the steel that in some cases literally built America and then sat vacant for in some cases decades are now centers of advanced technology. And you mentioned that right next door to you there at Mill 19 is the Uber Advanced Technologies Group Autonomous Vehicle Test Track. You're standing right next to a building with these advanced robotic arms, and in the distance you hear cars slamming on their brakes and doing various turns as they're being tested. And you really feel like you're in the hub of what is perhaps literally building the future, just as the steel mills that used to sit there did. So it's a very interesting thing. But I meant, did you have something to say there?
No, I was just gonna say you're absolutely right. It's fascinating to think about that we're at the forefront of this, but 5 years, 10 years from now, this could be an amazing addition to Pittsburgh's ecosystem, right? And something that really makes us stand out. And so it's really exciting to be part of that. As a native Pittsburgher, that really gets me excited.
Absolutely. And we mentioned that the sites that used to be there were the steel mills, and then they went away. And when that happened, largely starting in the late 70s, carrying throughout the 80s, much of Pittsburgh's population was unemployed. There was an era of depression here in the city. And there's a lot of fear that with robotics and automation, that could return on perhaps a national or a global scale. There's a lot of fear of robots and automation putting people out of work. But it's very interesting to hear the Arm Institute talk about these things because your vision of the future seems to not be factory floors filled with robots, but factory floors filled with robots working alongside humans. Tell us a bit more about this. What is Arm's vision for the future?
Certainly. And just to touch on your point, because as the marketing person here at ARM, I deal with these stories every day, right? Robots are bad, robots are taking away our jobs. And, the fact is, automation has been around for over 500 years. And every time we go through a cycle of automation, and we see jobs disappear and see new jobs created. And this cycle isn't any different from any other cycle that we're going through. And so I think a lot of times fear comes evolved because it's not readily clear what the new path will be, which is hard because who can predict the future? But what I can tell you is that you watch the Terminator and kind of movies on TV, those are not real. Those are not the robots that you will see in manufacturing. And honestly, those aren't robots anyways. Those are figments of filmmakers' imaginations. What you'll see is a movement towards what's called collaborative robots. And collaborative robots simply means that. It simply means that when you look at an assembly process for anything that's made, right? And when you think about it, everything surrounding you right now was made in a factory somewhere, pretty much, right? And there are multiple steps for things being made. And some of those steps could be jobs that are dirty or dangerous or dull. We always talk about the 3Ds of what robotics helps with. And so what we really envision is an environment, and you'll see this in some places today, where the robots are doing those jobs and the people are doing the jobs that are safer, that require more brain power, that require problem solving capabilities, right? And then together they work the most efficiently to get something done. And in order for that to happen, a lot of the things that we're doing with the project that we're funding is to move towards that goal. Because right now, robots aren't highly flexible or easily reprogrammable. They're very good at programming them to do one task over and over again. But if you're a small machine shop and you're doing custom manufacturing and you need to change the products that you're producing, maybe multiple times a day, it's a lot harder to get a robot to do that, right? And so focusing on things like operating system extensions, a common operating system, more safety issues, more flexibility, easier to reprogram, having a person with not necessarily engineering skills being able to manage a robot, all those things are critical in order to advance the use of robots in manufacturing. And those are the types of projects that we focus on. So none of our projects focus on getting rid of people. All of our projects focus on how can people in factories take the most advantage of advanced technology and automation to allow them to produce products that are of higher quality, that allow their workers to be safer because we're not putting them in dangerous positions, and allow them to better respond to the marketplace needs if they've got custom needs. The nice thing about robots is it doesn't really get bored doing the same thing over and over again for 24 hours a day. People get bored, right? People get bored and their mind wanders and maybe they cause a defect, because it's not a very exciting job. So if we can give the robot that job and give the human the job that is more exciting, uses their brain power, uses their imagination, allows them to be involved with even thinking about how to better use that robot, then everybody wins in that scenario.
I'm totally on board. I'm 100% in favor of replacing much of human labor with robots and automation, so I'm very excited to see the technology that you're developing. So during my visits to ARM's new headquarters at Mill 19, I saw the robots for various projects that you currently have in your high bay. But there's a lot of additional room there. How do you determine which projects are going to be based in-house and which are going to be based elsewhere?
That's a great question. Right now, we have a lot of space that we are anxious to fill up. So we're in various discussions, and we kind of look at things in a couple different ways. We really like to call this area a prototyping or a de-risking center. So, for instance, we're doing a project with a local manufacturer on robotic grinding. It's a cabinet maker that's local, and you need to do some grinding when you have a steel cabinet to smooth out all the edges before you deliver that to a customer. And so we're embarking on a project where we're going to see, instead of a human doing all that smoothing, whether a robot can do that smoothing for those cabinets. So because we're just getting started right now, we're looking at what's out there, what's available, what we can start to work on today. Over time, what we anticipate is these projects will rotate in and out. So it won't be the same projects every time you come here. And it really will be based upon, is this something that we can test or prototype or remove the risk from? Or is this something that we think is so fantastic and different and innovative that we want to be able to show that off to the visitors that we get here on a very regular basis?
So as we wrap things up here, I'd love to look to the future. What does the future hold for the ARM Institute? What do you want to do in terms of growth or in terms of projects you want to tackle, or what do you see for the future of this organization?
So we aspire to be the first place that manufacturers come when they want to understand what technologies may be available for them, when they want to improve automation in their environment, specific to robotics and AI. So we always say, like, we want to be the first call. So we want to become the industry expert on where robotic technology can go to help a manufacturing situation. And we want to be a provider and a supporter of products and services that help that industry grow. So again, just to have that national brand and awareness that there's this amazing institute funded by the federal government here in Pittsburgh, which is where it should be, because this is the heart of robotics and AI and manufacturing, and that we are showing the United States and ultimately the world what the factory of the future can do, but we're doing it in a way that's very practical and in a way that is demonstrable and usable.
I think this was a very important conversation because of the people who know about the ARM Institute, which is quite a few. Everyone knows that you're doing very interesting and important work, but I feel like most of those people cannot actually describe what it is that you do and how you operate. So I'm so glad to have had this conversation to explain it to people, and I'm coming away learning a lot more, and I'm sure that the audience is as well. So thank you for taking the time to speak with me about this, and I really enjoyed this conversation.
Thank you, Ryan. Well, I appreciate the opportunity too. I've been in marketing for a long time. This is probably the most complex product I've had to market because of all these different things that we do. And so it's great to have that discussion with you to really get into what we're trying to accomplish. If anybody else would like to learn about us, our website is arminstitute.org. And we would love to share our story with others. And we'd love to have you come visit us as well.
I will put links to those resources in the show notes at futuregrind.org, and thank you again for joining me.
Thank you, Ryan.
Hey everyone, Ryan O'Shea again, and thanks for listening to my interview with Suzy Teele. Remember to check out the show notes and more at futuregrind.org. Make sure to subscribe, leave a review, and you can also like, comment, and share to spread the word. We also need your help to keep this podcast running. You can donate at futuregrind.org/support or make a purchase at futuregrind.org/store. Once again, we want to thank our sponsor, the Smart Manufacturing Experience, taking place June 2nd through 4th, 2020 in Pittsburgh. Thousands of manufacturers from across the country attend this event to learn benefits and implementation strategies for smart manufacturing. Be the expert they turn to for answers, innovations, and know-how in Industry 4.0. Smart Manufacturing Experience focuses on industrial IoT, artificial intelligence, automation and robotics, data analytics, additive manufacturing and 3D printing, augmented and virtual reality, cybersecurity, and workforce transformation. Be part of the experience. Visit bit.ly/SMX2020 to learn more about becoming an experience partner. That's bit.ly/SMX2020 to learn more about becoming an experience partner. Till next time, this is Future Grind.